ladies and gentlemen, get ready to be inspired by our next speaker for the day, who is a true master in the world of systems and applications. Currently serving as the head of DevOps at Lenskart, he's not just building systems, but he's also shaping the very culture of innovation. With a knack for designing highly available and scalable infrastructures on cloud platforms, he's a driving force and promoter of the DevOps culture within organizations. Okay, so moving on. So in his role at Lenskart, he is on a mission to break silos and bring the best practices of chaos engineering, data ops, and DevSecOps to the forefront. As a speaker at our conference, he will unravel the intricacies of AIOPS, the rise of automated data-driven systems, and the transformative power of cultivating a robust DevOps culture. So ladies and gentlemen, get ready for a very enlightening session ahead of you with a true pioneer at the helm. Please put your hands together for the one and only from the Lenskart team, Mr. Rajdeep Bhattacharya.
Hey, hi guys. Good morning. A lot of, I think, insights around resilience and cultivating more green energy. A lot of key takeaways actually for me, and I would like to actually tell from the last 2 quarters, we have started putting our carbon footprint emission in our quarterly presentations, right? Although right now nobody is looking at it, but I'm sure that over a due course of time, we are DevOps people, right? So we bring in the change. So I think over some period of time, these things will be taken seriously. I'm Rajdeep. I'm leading the DevOps initiative at Lenskart, and so my topic for today is about AIOPS. Just wanted a quick raise of hands who all have heard it for the first time, or some idea about it. Cool. Yeah. So I think it's a pretty new topic, at least for us when we were maturing our systems, right? So during this period, of hello, I'm audible, right? Yeah. So. Okay, so during this period, of DevOps transformation, right? I'm not. Hello. Yeah. So during this, period of digital transformation, or moving to more of DevOps practices, what are the, kind of advantages the companies actually gained from it, right? See, one of the, okay, I think you're not able to see, I'm going to speak about it. So, one of the key things that, companies got from, implementing a successful DevOps culture into the company was release velocity, right? The second thing was, improving the cultural aspect within the organizations, right? They brought the teams together much closer, not just the tech teams, but cross teams as well. Another thing was faster scaling of the infrastructure, right? Bringing in more of cloud native architectures, microservice, Kubernetes containers, right? Different other factors contributing to it, right? Sorry, my presentation got I was using a Zoho presentation. So I moved to Microsoft, so this effect got dropped. So anyways, another thing was better observability into the system, right? Self-service tooling, right? We started getting more into the platform side of things, especially with a lot of companies adopting Kubernetes, right? Or they moving to a common framework of operations, right? They started, building more of tools to basically make this acceleration even faster, right? Especially with the shared responsibility into the picture, more and more teams wanted to do things on their own, right? And the last thing is the resiliency engineering, or some of us know it as chaos engineering. Along with that, shift left approach into the security side of things, right? So, you know, so if these were the things that were getting solved, then why do we need any other kind of newer aspect to the picture, right? Why do we need to look at different other things, right? If DevOps is doing everything for us, right? Now, when a company, they evolve from, they are evolving from a basic system admin to slowly evolving into a more of a DevOps kind of mindset, right? A lot of cultural changes happen, and the velocity, is, at a, at an unprecedented level, right? Which is not humanly possible, right? So one of the key challenges the DevOps team face as a next level of challenge is your detection of the issues in your SDLC, right? How can you find these issues faster, even if they get introduced into the production environment? Next is the code testing challenge, right? Now the development is happening at a crazy pace, right? The deployments happen at a crazy pace, right? But where does this testing, how this testing cycles is maturing, right? How good is the quality of the code? What are the different measure or metrics in which, you can say that your code or the software that you are running is compliant, right? Next is, I think we already talked a lot about this, so costing, right? So that's the biggest challenge, for everyone. So how do you find faster, in a faster way, that the costing that you have maybe worked out with your finance, is your infrastructure compliant with that, right? What are your, compute utilization index levels, right? These are some of the factors, which we started measuring, right? As in the panel discussion, the first thing that was told that, in all these initiatives, you first start with measuring things, right? Unless and until you don't have a measure of things, you don't know where to go, right? And that is where you start first measuring things. Another major issue is that, we have reached to a point where we have automated things, right? But, this process is still, somewhere between a semi-automatic and an automatic process, right? And in some cases even manual, right? In some cases you still go and look at some data or alert and take actions, right? These are not, in some cases you don't know what are the consequences if you, let's say, automate that process, right? Another thing is, taking real-time action. Security is becoming a big issue, right? Every companies are facing a lot of DDoS attacks. A lot of code changes are happening frequently. With every code change, there is a possibility that, some security might get introduced. A case like Log4j that happened, right? Companies, they were bound to take quick actions, right? Otherwise, you are at the mercy of the somebody trying to compromise your system. Another thing is the, scaling your system faster, right? Not a reactive way, right? Because see, when you are into this mode where you are scaling things, right? You are marketing your products, you are bringing in new initiative, new experiment. A lot of things are happening pretty fast. Every time you can't expect the teams to come and tell you that a certain promotion is going to happen, right? Your system should be proactive to basically scale up in those cases, right? Now this is a standard basically of automation, autonomous operations, right? Not just for the technology, but for any mechanical or technical operations. This is a 5-level automation matrix where companies, they basically start somewhere from level 2. In many of these factories there is also level 0, right, where it's completely manual effort. The objective is to slowly graduate to level 5, right? Where, you don't need any human to basically act on an issue or an incident, right? And it is some way it's taking care of itself, right? So considering these factors, the new, dimension that opens up is called as AIOPS, right? It is nothing but basically taking a data-driven decision, right? So basically using your data to analyze and then act upon, right? Not just any, human coming and monitoring the system and then taking an action, but taking action based on some data points, right? So this is why I asked, how many of us know this? So basically sitting at the center of this AIOps are machine learning models, right? So what is a machine learning model? Basically it's a file, right? Which is basically has a, based on the collected data points, there are certain patterns, right? And there are algorithms where, based on, the accurateness of a particular event and the correlation, you basically take an action, right? So these are models, you use GPTs, chat GPTs and all these things. At the back end, it's basically crunching a lot of data, right? So this is a 10,000 feet view of an AIOps architecture, right? Where what basically you are doing that, you are collecting data from different sources, right? From your data centers, your logs, your, CMDB systems, or your cloud infrastructure, and you are crunching this data into some sort of an, you call it big data, you call it operational data lake, right? And you are analyzing this data and forming correlation patterns, right? So because, once you get an incident, basically there has to be a correlation to basically define a particular predefined action, right? Let's say I want that, if suddenly there is a surge of traffic, my pods or my system should scale to this level, right? You must be seeing Hotstar, right? Right. So a lot of scaling is happening, right? They are reaching a crazy numbers, right? So those numbers you can't predict, right? You are going to millions of traffic. You can't keep on somebody sitting on a system and he's doing a manual scaling. That is not, feasible from the business perspective. Also, it's basically humanly very challenging thing, right? So in AIOps, basically what you do is that collecting these events, you form a correlation and you basically build some sort of a notification or an action, right? Or basically some sort of a incident management that you do to automate this whole process, right? So what are the different kinds of, AI models, right? One is a bit static in nature, which is your offline AI model. It is basically, you have certain data set and it's not changing much. You basically deploy the model into the production. The challenge with offline model is that, if it is basically getting hit, if you are deploying it, you might be facing the unprecedented challenge of facing a downtime, right? So basically you bring in a lot of our DevOps practices to deploy these offline models. Then there are these online models, right? Which basically continuously keep getting data, and based on that, it learns and basically, kind of refactors the model, right? Now in AIOps, there are three classification of events, right? One is your negative, where you basically get incidents, outages, right? Any kind of security, things like DDoS and all, right? Those kind of things you get as negative events. There are positive events which are kind of new to the system, right? Where your machine learning is evolving the model. It's a new data set for it. And it is a positive event where it matures the model. And the third one is neutral event where no action is required, right? So it's a neutral event. This is basically a HDLC cycle for a AIOPS change management, where from a design dev to a production deployment happens. It happens just like any other, SDLC process. The deployment is a bit tricky. I think that there is another session I saw about MLOps. I think it will be discussed in much more details. But these models are sometimes very heavy, right? So there are different challenges to deploying it, and needs to be taken care of while doing this, right? At Lenskart also we have different models, right? Those are different precision models we use for our home try-on feature, where you bring in the app and it basically detects your face, right? So that is another, example of a offline model, right? Where we crunch, these models based on a lot of historic customer data, right? Now this is a, release classification for a AIOPS model, where, you are following the SDLC, and after, the offline training, basically there is an online training process where, you are maturing the offline model based on the data, which is it's receiving, right? So there is basically a versioning system that is followed to basically help, the teams who are working on this to identify that what sort of change is this, right? Is it a minor or a major, right? And also the configurational changes, right? So this is a classic example where, when you are integrating it with the CI/CD, this is how you basically store these artifacts, right? These models. So at the end, to summarize it all, right? Because I wanted this to be 10,000 feet view. AIOS basically helps in, eliminating a lot of these anomalies from the system, which humanly it might be time consuming, because MTTR and all these MTTI, these are very important factors. Now, business don't want to go down, and if they go down, they want to quickly recover from those systems. Second is the data-driven automation systems, which basically takes care of itself, right? The third one and very important one is that it takes the, those false positive, false negative cases, suppose you log into a monitoring system and you saw that, okay, there was an incident, right? But no way do you know, because it's right now a very reactive process that you are maturing your metrics, right? The SRE team sits, it evaluates the historic data and then compares and then, sees that, your indicators need to be fine-tuned or not, right? So in this case, it's basically giving you a right picture, which is there at this point of time. The fourth point is, the right sizing opportunities, right? Right now, again, most of the teams are doing a manual way where they would over provision their infrastructure a bit, and so I see a lot of smiles, right? So they will over provision a bit, and that system will scale so that there is always a headroom, right? Now, what if that, you could actually scale those systems on the fly, right? So this basically, we have seen that trying out different processor families and also, trying these scaling options. We are also experimenting with vertical scaling as well, very aggressively. Horizontal scaling, we have seen that lot of wastage goes away. It's a double-edged sword, by the way, right? If you don't tune it properly, it might work the other way around as well, right? So it also leads to green ops, right? So because, as I said, two factors that we started measuring. One was our wastage percentage, right? Every company has their wastage percentage, but where do you stand, right? And it's not just about the cost, right? It's also about the emission, right? So, and how much of compute utilization unit you stands on, right? So in our last quarter, we were on 0.33. This quarter, we are on 0.31, right? So basically, there are levers that how do you benchmark, are you an efficient, utilizer of these systems? In the same way, software, I was seeing, the slide before this, that how are you basically measuring your code quality, right? How efficiently the code is written, right? Because see, infrastructure scaling I can do to a level to basically, what do you say, utilize it properly. But efficient code is also very important. What sort of architecture is there is also very important, right? And the last one is basically the impact on security incident in real time, right? I like to basically tell you a case we faced at Lenskart, right? So last month we faced, I think, maybe the biggest attack by any e-commerce. We didn't publish it, but we faced in 3 minutes 41 million traffic on our website. And good thing that Cloudflare was able to block 8 million and the rest we were able to soak, right? So these are the examples, where, because, if you get traffic, you can't say to customer that, wait, I have to serve, right? I have to serve malicious traffic. Whatever you get, you have to scale. You can fix the anomalies, right? You can fine tune your WAF rules or you can fine tune your other scaling rules, but you have to scale up at that point of time and serve, right? As well as blocking, right? So blocking and scaling, right? That is happening in parallel. So right now, what is kind of a decentralized process? Because let's say you get a malicious query, right? And your application is waiting on that, right? Your database is overloaded, right? Now these are different teams right now operating at a different levels, right? And somewhere down the line, they might be sitting on a different call, but the operation is different, right? Now how do you close this operation into a single operation? And it is all data driven, right? So what they were doing manually, now it is entirely dependent on a certain pattern. It's doing a pattern recognition and taking this on its own, right? So your MTTR is definitely going to be improved with this, right? So I finished this fast because I wanted to take some question. I don't know if I can. Yeah. Yeah. I think Mike. Yeah.
I want to know how it recognizes that it is a malicious attack, because during Brick Million Day, as you said, millions of requests will be coming to the e-commerce website. So how do we actually differentiate between the malicious attacks and the real customer traffic?
Okay. So see, what we have seen in our platform is that, so there are a few examples, right? And this is a perfect example of AIOPS, right? So somebody who is hitting you at that rate, let's say somebody is doing a DDoS, right? He might be using some client, right? Is that client signature valid, right? What kind of URL he is hitting again and again, at what rate he is hitting, right? And what is he using it from the same IP or different IPs, right? So these are some of the patterns, right? You can recognize, and over a period of time when this model builds or data matures, right? You can take an immediate action, right? So when we started using this, right, we were able to block such malicious traffic at 3 minutes interval, right? But during this 3 minute, maybe, we would get, let's say, 2 million, 3 million, 5 million traffic, right? Now this traffic is not going to convert into any business for us, right? And we also spend infrastructure, right? And also it resulted into some sort of carbon emission as well when we scaled up, right? So we tuned our, rules at the Cloudflare level. Cloudflare at the backend also uses machine learning only, right? So it basically matured that, data, and now it is taking an action in 1 minute, right? Slowly you can also inject things like your client recognition, right? Inject some header into your client, right? To basically identify that which is malicious traffic and which is not, right? In this way, maybe we can even come down to, and we are doing that, we can also come down to maybe, let's say, 10 seconds, 30 seconds, right? I think these are some of the steps you can take. And also there are some standard, OWASP. Huh?
Captcha code forensics is a human.
Yeah, yeah, yeah. We don't put CAPTCHA because we don't want to show them that we have been attacked, right? So we do it a bit different way, right? We do it a bit gracefully. We don't shut down the door. So we basically try blocking them, right, and let the others come in, right? But yeah, CAPTCHA is so there are different techniques, right? CAPTCHA is also one of the techniques. Agreed. Yeah.
Automation is a great boon of AIOPS, but how do you handle false positive and false negative cases in a production scenario or when it's very important to figure out the actual output and correct output?
Okay. So basically, the first thing is that you define a baseline, right? I'll explain you with an example, right? So let's say that you are using AIOPS for a data-driven system, right? A database, right? Let's say that you don't want any query to basically exceed to a certain threshold, right? Or a CPU utilization, right? And when it does, basically, you are considering that as an anomaly, right? So here you are first defining the baseline, right? That this is my CPU utilization, and this is my query time, right? Beyond, if this crosses this threshold, I want somebody to take an action, right? And I know many of the database systems, some of the database systems are here which are doing this. We are also implementing it. So what basically the idea is that scaling database systems horizontally, right? Let's say some release went, right? And let's say it was not identified in your staging or pre-production environment, right? It went to production, right? Because of the data set reasons or whatever. And it hit your production. And now if that query got executed, your database is under tremendous load, right? Now your application also needs to scale, right? While it is, because the query is getting stuck, your application needs to scale. Somebody needs to kill that query and also scale the database system, right, to counter that CPU. Now here you have a case where slowly you will keep, you are collecting these data points, right? You basically, in case you will collect, let's say, MySQL log, slow query logs, right? And you will keep on seeing that, okay, what is this kind of query pattern, how much time does it take, right? Is it a new query? If it's there, then probably it will be a positive case, right? And whatever I showed, right? A new case, it will be a positive case. Then that model needs to mature in that. If it's already a negative case, then probably, it will see that, okay, based on this pattern, what is the average or standard deviation time? What is the time it's taking? And based on that, it will take the action. So this is a similar kind of pattern, like the case of anomaly detection in DDoS attack, right? What is the frequency of a per IP that you suddenly got, right? Issues don't happen when the traffic is consistent, right? Let's say somebody is hitting you at a pace of, let's say, 10 requests, right? And this is basically a scapegoat for attackers. They will maybe hit you 10 times and stop, right? I think that is DDoS is a very lazy way to bring down a site these days, right? Where you will suddenly in 1 minute or 2 minutes maybe hit the site so many times that you go down, right? In most, I think 80-90% of the cases the traffic will get blocked, but somebody is basically collecting that pattern, right? That okay, based on this rule, this guy is hitting so many times. This does not seem to be correct, right? Let's say in 1 minute he has, or 2 minutes he has hit the site, let's say, 1 million times. Now this is not a human pattern. And also the browser signature and different other things, right? So based on that, I think this is how you basically form a baseline, and you just keep on adding data points to it. And this is what basically building a model is, right? Based on a certain matrix, you keep on crunching data, and you derive from there. So MLOps basically is the identification and correlation of the data, right? Artificial intelligence basically is when you use that data to take some action as well, right? So basically there is a data flowing in, there is a source, right? Then there is basically a refactoring of the data, cleaning of the data, correlation, right? and basically you are coming up to a baseline, and then there is an action also, right? So this whole cycle forms the AIOPS.